For my standard 4.1, I chose to do question 4.3 from the textbook, and it asks us to consider the two-particle entangled state shown here. It says show that the probability of observer A measuring particle 1 to have spin up is 50% for any orientation of the Stern-Gerlach detector used by observer A. To find this probability, sum over all the joint probabilities for observer A to measure spin up and observer B to measure anything. From the question, we know that the only two pairs of results we are trying to find probabilities for are spin up for both observer A and observer B, and spin up for observer A and spin down for observer B. Because observer A, we're only looking for the times where it's detecting a spin up, and then observer B has a choice of either detecting spin up or spin down. So that leaves us with two choices. So the probability that observer A detects spin up and observer B detects anything is the sum of both of these. So this is the probability of both observer A and observer B observing spin up summed with the probability of observer A observing or detecting spin up and observer B detecting spin down. For a system of two spin 1/2 particles, we can calculate the probabilities using concepts from early chapters. Let's assume that observer A records spin up along some direction. Let's define this direction to be z hat. Then observer B measures along another direction, it's called n hat, at an angle theta with respect to the z-axis. Then we can write the probability that observer A records spin up along the z-axis and observer B records spin up along n hat along the n hat direction as this. Now we can substitute in the entangled state and the direction eigenstate this to solve. So our probability for observer A and observer B both detecting spin up is this once we sub in for our direction eigenstate and our entangled state, and we find this to be 1/2 sine squared theta over 2. And again, that theta is the angle that the n hat is away with respect to the z-axis. Following the same logic, we can solve for the probability of observer A reading spin up and observer B reading spin down. So then again we have this. We can sub in the entangled state and the direction eigenstate to solve again, and we find that this is equal to 1/2 cosine squared theta over 2. Summing these two probabilities together, we find that it is equal to 1/2. So our probability is equal to 50%. So thus we have shown that the probability of observer A measuring particle 1 to have spin up is 50% for any orientation of the Stern-Gerlach detector.